Hi, Blake. What type of technologies are farmers using now, and what are the advantages compared to, say, previous methods? I mean, obviously the hoe, right?
Yeah, so now farming equipment manufacturers are implementing MIMS-based accelerometers and gyros for autonomy, but as well as just positioning, or very accurate positioning.
Very cool. What kinds of farms are adopting this technology? I guess it works mostly for grain, or am I wrong about that?
Yeah, all different types of farms. So anytime you want to accurately position a piece of equipment, you can implement this technology. And we're seeing kind of the younger generation of farmers be more inclined to implement this technology, especially if it can prove to yield better results. So if we have higher crop yield or more efficient farming methods or better processes because of it, we're seeing that implemented by kind of the younger generation of farmers.
Is it North America or everywhere?
Oh, basically everywhere. In fact, I would say some countries are actually ahead of North America in this
Yeah, it sounds like that happens with a lot of technology. So what are one of the main features industrial users rely upon when employing these kinds of sensors?
So the main focus is generally, above all, accuracy, because these are really big machines, right? And the other thing is stability over time and temperature. So a lot of this equipment is in the field for decades, and we can't have the measurements drift on either any of the axes over time. And they're also used outside or outdoors in all different seasons. So we can't have the measurements drift over time or temperature. So this is an extremely important parameter for anybody evaluating these types of products to look at. We are also very concerned with vibration and shock resilience. So we can't have vibration or shock kind of influencing the measurement, because these are mounted to machines that will vibrate and do go through a lot of shock. So we have to be careful about that as well.
And they're affected by heavy wind and other things like that.
Wind, movement, if you can consider kind of pulling something through the field when we hit a rock, we have to make sure it doesn't affect the measurement, something like that.
In that example, would you have AI or other methods to correct for it, or does it just mean that the sensor stops and then restarts?
A lot of the time it's actually kind of filtered out. So our products are very stable or robust, I guess, against vibration and shock. And we can actually of course we're measuring that shock, but we can actually filter it out on the output.
Wow, very cool. Is there a difference between an industrial sensor and consumer grade? I mean, I know the obvious difference. It's who uses it.
Yeah, so these are completely unlike accelerometers and gyros that you would find in your cell phone from flip it from landscape to portrait. First, easiest distinction is they're a lot bigger, and that's because the elements inside are a lot bigger. Bigger elements mean bigger masses, which means better signal-to-noise ratio, higher accuracy, and we can also kind of fill the cavities with different gases to change the dampening characteristics of the mass. So this kind of goes into surviving very large shocks. If you can imagine construction equipment or farming equipment has the ability to be shocked really high or really hard. So we need to be able to survive those as well.
And Murata's doing all that?
Yeah, we're doing all that in our facility in Finland. So we're doing all of the design, all the manufacturing. We're manufacturing about 75 million MEMS elements per year now. And we're doing all the package and ASIC design as well.
And sold globally?
Globally, that's right.
Yeah. Is North America one of your bigger markets?
Yes, yeah. North America is quite large for us, and we've been quite successful within North America so far.
Well, what's your take on the future for ag tech in the sensors field?
Yeah, so when I think about the future of agriculture in any country, I would consider picturing machines that are much more like robots than actual vehicles. Now we're seeing lots of tractors, towing equipment, but in the future I think we'll see robots that can not only pick the fruit or pick the weeds out of the ground, they can actually determine what the weeds are or determine the ripeness of the fruit, then sort it based on the color or the shape or the ripeness, and then deliver it to the farmer. Or we could see kind of cabless electronic or tractors with electric motors towing smart equipment, and the farmer is just sitting on the side monitoring all the vitals of the equipment in the field and then monitoring the output. So a lot less actual handwork.
So as the future is wheels will drive these things, or are we going to see bipeds?
I think we'll see a combination. So Of course, wheels will drive kind of the bigger machinery, I think. But if you have a very oddly shaped farm or a farm or a crop that is difficult to be managed by humans, then we might see a lot more kind of flying equipment and things like that.
Wow, it's really cool, Blake.
Yeah.
Thanks for the time. Appreciate
Yeah,
it.
thank you. Appreciate it.